Today we are going to be working on functions. So today we're going to go through graphing relationships, what exactly is a function, we're going to look at how to utilize functions within tables and graphs, and we're going to talk about the vertical line test. So some keywords within graphing relationships are horizontal, slanting upward, and slanting downwards. So now let's recall. Do you remember how to fill out the table of values based on a given graph? So let's go ahead here and complete the table of values. So feel free to pause the video and try for yourself. All right, so hopefully you paused it and tried it for yourself. So now I'm going to go over it. So we're going to go ahead here and remember that our x values is on the horizontal and our y values are on the vertical. And now when we write, or when we fill in our table, we're just going to find our dot and look down at what number it's at. So for the dot circled in black, our x value is 2. And then if we look to the right, our y value is 2. For our next dot, we have an x value of 4 and a y value of 4. For our next dot, we have an x value of 6 and a y value of 6. And then we have an x value of 10 and a y value of 8. And lastly, we have an x value of 12 and a y value of 12. So now we have completed our table. So great job. Hopefully that was a nice review. So now let's consider drawing a graph. So to draw a graph, we either need a general idea, so that's what we're going to do below, or you need an ordered pair to tell us where the graph should go. And we can get that ordered pair from a table or from points on a graph. So an ordered pair typically goes x value, comma, y value. And it relates to the x and y axis. So let's do one that's just the general idea of the types of lines. So once again, I'll give you a few minutes to try it, and then I'll jump in and give you the answer. So draw a graph where the temperature sharply declines, then steadies to a constant, and then increases. So go ahead and pause the video and try it for yourself. All right, so hopefully you have paused the video. So we're going to start here. The first thing it's going to do is sharply decline. So for that, I'm going to start up maybe at like 12 and then make a very sharp line down to, let's say, like 2.5 right here. And then it's going to steady to a constant, which means just a straight line. Just draw it for a little bit. And the last step is to increase. Now it doesn't say increase sharply, so I can draw a little flatter. So we get something that looks like this in a general idea. So hopefully your graph looks similar to mine. Alright, so there's two types of graphs, generally speaking. One is a discrete graph and it only shows points, and the other is a continuous graph. And this is where you connect the points and you get some sort of line or curve. So let's go ahead and do our first practice problem. So we have our axis and we have our table, and then we have some ordered pairs. So first what I'm going to do is I'm going to write the ordered pairs in the table. So remember, our ordered pairs always start with the x and then go to the y. So for -1, -1, I'm going to have -1 in the x, -1 in the y. So this is x, y, x, y. So the next pair is 1, 1. We have our x, y, 2, 3. Then we have our x, y, and this is 3, 2. So now we can graph it. So So let's see, I'm going to use orange. So -1, -1. So how I'm going to do this is I'm going to go over -1 and then down -1. So I'm going to go, let's use yellow, over -1 and then down -1 to find the point -1, -1. So some prereqs for this is knowing how to read a graph and knowing where to plot the different points. The next one is 1, 1. So I'm going to go over 1 and up 1 because it's positive. And then for the next one, I'm going to go over 2, up 3. Then lastly, I'm going to go over 3, up 2. So I'm going to get a graph that looks like this. It doesn't tell us to connect them, so I'm just going to leave it as a discrete graph. So this one, I'm going to help you by filling out the table, and then I'm going to give you a moment to try to graph it on your own. So once again, we have 4 ordered pairs. They're in the form x, y. So if it's helpful while you're first starting out, feel free to put like an x, y above all of the coordinates to help you remember which one is an x value and which one is a y value. So I have 0, 4, -4, -4, -2, -3, and 4, -1. So go ahead and take a few moments to try to graph it on your own. Alright, so hopefully you've taken some time to graph it on your own. So let's go ahead and I will show you the graph. So we start out with 0, -4, 0, up 4. So when you're considering coordinates or a table to your graph, you want to start with the x and go over, then up, or over, then down. So next one is over -4, down -4. The next one is over -2, down -3. And the last one is over 4, up 1, or down -1. So over 4, down -1. So we get a graph that looks like this. Once again, this is a discrete graph, doesn't tell us to like connect the points or anything. Alright, and then for the final one, I'm going to have you all pause the video momentarily and try it on your own. Alright, so hopefully you've paused the video. So this time I'm not going to fill out the table, I'm just going to go ahead and graph it, and let's see if your graph looks similar to mine. So we go over 3, down -2, over 1, up 0, over -2, up 4, and then over 3, up 2. So it should look something like this. Alright, so now what are relations? So a relation is a relationship between a set of anything. It could be a set of ordered pairs, like in this image here. It could be a graph, like here. It could be a table, like over here. Or it could be a mapping diagram, which just shows which x's go with which y's. So now we're going to get into what is a function. A function is a special type of relation in which one domain value, or the x, only has one, so that's very important, one range value. And range value generally alludes to a y. So the domain is the x-coordinate in an ordered pair, and the range is the y-coordinate in an ordered pair. So let's look at some domain range questions. So I'll kind of show you what we're looking for in the first question, and then I'll have you all pause the video so you can work on the others on your own. So our domain is all of our x values. So here we're going to have our x value here is 4. We have an x value of 3, an x value of -2, an x value of -7, and an x value of -4. So you're just going to put commas in between them. And then for range, we have now range is our y values. So we have a y value of 5, a y value of 9, a y value of negative 8, a y value of 7, and a y value of 9. So we are just listing them out to get familiar with what domain means and what range means. So go ahead and try the next 3 on your own. So please pause the video and work on it, and then we'll come back together and review it. Alright, so hopefully you have attempted the questions. So let's go over the next one. So domain is 1, 6, 0, 9, and 6. And range is -7, 0, 2, 6, and 6. For the next one, domain is -9, 0, -8, 3, and 7. And the range is -4, -6, 2, -7, and 5. The last one is -8, 0, 9, -3, and 0. And the range is -2. So -2, -7, -3, -3, and 0. So in this case, the x values of the domain are the first number in the ordered pair, and the range or y values are the second number in the ordered pair. So now let's look through some with a diagram. Now this mapping diagram here may look confusing at first, but I'll talk you through a couple. And we're trying to determine, is this a function? Now, if we remember, the definition of a function is each x value. So it's each x value only has one y value. So the first one, if we look at it, we have our 2 matches with our 5, our 5 matches with our 0, and our 6 matches with our 2. So we get the ordered pairs 2, 5, 5, 0, and 6, 2. So everything has their own numbers. So this is indeed a function. So yes. Now if we look at our second one, we might notice there's quite a bit more lines. So if we notice here, 1 has the x value, or I should say each y value only has one x value. So if we see here, the 1, this is our y's, by the way, this is our x's. 1 goes to 0, 5, and 9. 9 also goes to 4, and 7 goes to 4, and then 2 goes to 5. So even though 2 is only going to one number, 4 and 1, so 4 has 3 x values going to it, and 4 has 2 x values, so this is not a function. So no. So go ahead and try the next 2 on your own, and we will go over it. Alright, so hopefully you've taken some time to pause the video and go through the last 2 problems. So the next one, we have 1 and 9 both pair with 8, 5 and 8 both pair with 6, and 8 also pairs with 7. So therefore, this once again is not a function. Because we have multiple y values having multiple x, or we have each, at least one y value has multiple x values. And the last one is a function because we can make our ordered pairs 2 pairs with 4, 3 pairs with 3, and 8 pairs with 9. If the diagrams are a little confusing, feel free to write them out in ordered pairs, and you should see each y value only once. So in the case of the first and fourth question, we see 5 once, we see 0 once, and we see 2 once. In the case of number 4, we see 4 once, 3 once, and 9 once. If I were to do the one on the bottom right, I would get 1, 8, 5, 6, 8, 6, and we see 6 here twice. So that tells us, so we see 6 in the y position twice, that tells us it's not a function. And lastly, we're going to look to see if these graphs are a function. And this is where I'm going to bring up the vertical line test. We'll get a definition a little bit later in the slides. But for now, how the vertical line test works is you just draw a line, so technically you can hold your pencil vertical ways up across your paper, and if your pencil hits the graph at multiple points, then it is not a function. So in this case, if I were to draw, let's say the pink line here is my pencil, we see that the pink line passes through the graph once, twice, and 3 times. So since it passes through 3 times, it fails the vertical line test and is therefore not a function. Now this next one here, let's say I draw my pink line, or represents my pencil. It passes through the line once, so it passes vertical line test. And it therefore is a function. So go ahead and pause the video and try the next 2, and then we will go over them. Alright, so hopefully you've paused the video. So let's try number 3 and number 4. So this next one, I'm going to draw my line. And once again, we see it passes through once, so it is indeed a function. And for the 4th one, I pass it through. And you can choose any place on the line. It just has to be a vertical line. And I can put it through numerous places. And each one only passes my graph once. So the 4th one is also, yes, it is a function. So here's our definition of our vertical line test that I introduced in the last slide. So it is a way to determine if a set of coordinates results in a function. So how to perform it is use a pencil, ruler, or any other straight edge. You have a pencil usually in your hands, that's a perfect straight edge, and see if the line crosses the test more than once. To pass the test, it must cross the line only once, therefore it is a function, and if it fails the test, it crosses the graph more than once, so therefore it's not a function. So this is kind of looking at it. So we have the brown one is our straight edge. So if we see here, we have this circle in blue. So the circle hits through the vertical line. Here, I'll highlight it in pink. So it passes through right here and right here. So a circle is not a function. And once again, we still have our brown line, and it's passing through this orange graph, and it passes through right here at this point. So therefore, since it only passes through once, it is a function. This is an easy way to tell if graphically, if something is a function or not. So writing functions. So we have to understand our variables. So we have 2 variables, an x and a y. So an independent variable is the input of the function. It's the value that this variable determines that answers the output of the function, and this is usually the x. The dependent is the output of the function, usually the y. So function notation is y equals fx. You can also kind of think of it as y equals mx. If you've already learned about the equation y equals mx plus b, you can kind of ignore the b, and y equals mx is kind of similar to fx, except instead of using m, we use f because we're not always going to be looking at a slope per se. So let's take a practice at writing each sentence as an equation. So we have here 2 less than a number n is 52. So is going to relate to an equal sign. So I can make it equal 52. And then we have less, which relates to subtraction. So here you kind of have to think of it backwards because it's 2 less than a number. So because of the than a wording, n has to come first, and we have minus 2. So n minus 2 equals 52. Now we have, once again, 3 less, so less relates to subtraction. We have is, which is going to be our equal sign. Our number here is going to be the variable n, and we have 12. So 12 equals, and kind of like the last one, than a number means the number must come first, that's our variable n, minus 3 equals 12. Now, go ahead and see if you can try number 3 and 4 by yourself. So go ahead, pause the video. Alright, so hopefully you've paused it and at least attempted it, so let's go over it. So we have here the sum of 5 and a number is 10 less than 50. So if we see a number like sum, that means plus, and also kind of relates to plus, to add addition. So you have the sum of 5 and a number, so we can put 5 plus a number, is, this is an equal sign, equals 10 less than 50. Less than means that we have to put 50 first, minus 10. And if we simplify this, this gives us 5 plus n equals 40. So now here we have more also equals plus, and since we have this than a, the number n has to go first, plus 3 equals 60, because is an equal sign. So hopefully you can utilize the vocabulary and the specific terms used in a sentence to write your equations. So I'll quickly just highlight each of our equations, because I know it's a little chaotic. So hopefully that can help you kind of see what the equations we deduced are. Alrighty. So now we're going to look at graphing a function using the table of values. We already kind of went over this. So what you do is you construct your table, and as you get better, you won't necessarily have to do this. So what happens is sometimes they might just give you an equation. So in this case, they gave us this equation, y equals 2x. So what do you do with it? Well, they don't tell you what x values to use. Here, they use -1, 0, 1, and 2. So what they did is they just plugged it in. So y equals 2 times -1, that gives you -2. And if you see here, there is our -2. So you just plug in the x value you determined, and then you plot it. So here I would have -1, -2, 0, 0, over 1 up 2, and over 2 up 4. So I have this nice function here, because it would pass the vertical line test if I were to draw a line through all the points. Now not using a straight edge, so it's going to look a little funky. I can actually get rid of that. Let's see here how well I can do this. Okay, that one's a lot better. If I were just to choose any point for my pink straight edge to go through, that's not the best. It hits through it one time, therefore passes the vertical line test. Alright, so let's practice graphing some functions. So here we have f of x. Now you can think of f of x as just y. It's just a fancy way to say y. So we have y equals 3x minus 2. If you notice this is our y equals mx plus b equation. So b is our y-intercept. So I can put a dot here at 2. And 3 is our slope. So that means I'm going to go up 3, 1, 2, 3, and over 1 for my second point. And now I can draw a line through them. And there we go. There's our graph. So it's pretty easy when it's in something called slope-intercept form. So this here is slope-intercept form. Because we have our slope, our 3x, and our intercept, 2. So it's a really easy way to get a graph drawn. Now, in the second one, they give it to us in what's called standard form. So there's 3 types of forms for functions. There's slope, intercept, standard, and point slope. We're not going to do point slope today. We're not even really doing much with these equations, but I do just want to remind you or teach about them. So standard form is ax plus by equals c. A, b, and c are all some number. So here we have -2 is our a value, 1 is our y value, because kind of this is like an invisible 1y, and 3 is our c value, 1 is our b value. So there's a couple ways you can do this. So I'm going to show you both ways, and you can choose which way seems easier for you. So they give us our domain, they give us our x's. So our x's is -5, -3, 1, and 4. Now we can find our y's from this by plugging it in. So -2 times -5 is, so if I have here -2x, and I want to plug in my x as -5 plus y equals 3, I can do 10 plus y equals 3. I would subtract 10 from both sides to get y equals -7. So that is one way you can do it, and you can just keep rewriting out the equation on your own. Now another way is to switch around our equation. So right now we have negative, so this is way 1. It's just filling in the graph, the table, because they gave us our domain. Now the second way, we're going to switch from standard form to slope-intercept. So what this is going to look like is I have -2x plus y equals 3. So I want to get y alone because it's y equals mx plus b. So I'm just going to add my 2x to the other side. So I get y equals 2x plus 3. So now I can plug my x's in. So I get -3 times 2 is -6, plus 3 is -3. 2 times 1 is 2, plus 3 is 5. 4 times 2 is 8, plus 3 is 11. So you might find that switching the form is easier just to do the math, because you just have to worry about like that one side when doing the math. So it's a little less, you don't have to deal with subtraction. And then you would graph it. So we have here -5, -7, -3, -3, 1 over 1, up 5, and then 4, you can't really get to 11, so we'll just use these 3 points. There we go. So there's our line for this one. And that is how you graph a function. So lastly, what we did today is we worked on what exactly a function was, and it's a special type of relationship where each input only has one output. And we also looked at how to graph a function using a table